Good evening, sir. I am Shashti. My topic is web-based visualize for structural representation of C programs. Let me start from the introduction of the concept. Compilers internally transform source code into different structural representation before execution. These representation helps in understanding program structure, execution flow, and data dependencies. This project develops a web-based visualize that analyze C programs and displays tokenization, abstract syntax tree, control flow graph, data flow graph, code property graph. The system provides an interactive and visual learning platform for compiler concept. The next one, problem statement. Students frequently learn compiler concept theoretically but struggle to visualize how source code is processed internally. Important structures such as tokens, syntax tree, execution paths like this can be proceeded by this concept. Objectives. Primary objectives: analyze C source code, perform Laxial analysis, generate structural representation, visualize execution flow, display data dependencies. Educational objectives: improve understanding of compiler design, connect automata theory with practical implementation, demonstrate program analysis technologies. And next I am going to explain the tokenization. What is tokenization? In the sense, tokenization is the first phase of compilation. The source code is divided into smaller meaningful units called tokens. For example, int a is equal to 5. The token types keywords, identifiers, constants, operands like this, strings, etc. Abstract syntax tree, AST. It represents an abstract syntax tree, represents hierarchical structure of source code. It eliminates unnecessary symbols and focuses only on program logic. Advantages: simplifies program representation, supports syntax validation, helps code optimization, used for compilers and interpreters. In our project, AST is automatically generated after parsing the input program. Control flow graph, CFG. A control flow graph represents the execution flow of the program. It shows how control moves between different statements and conditions. Features of this CFGs are: displays execution sequence, represent decision making structures, shows program branches, helps to understand program behavior, how it works and how it behaves by giving the inputs. The project generates CFG using graphical nodes and edges to visualize execution path. And the next one is control flow graph, CFG. The control flow graph represents the execution of flow of the program. It shows how control moves between different statements and conditions. The features of CFGs are: displays execution sequence, represent decision making structure, shows program branches and behavior. Data flow graph, DFG. The data flow graph shows how data moves between variables and operations. The track dependencies among variable during execution. The features of DFGs can be seen as variable definitions, variable usage, data dependency, computational flow. For example, if A is equal to 5 and B is equal to 10, the addition of these two can be printed as C is equal to 15. This helps you visualize how information is proceeded inside the program. Next, code property graph, CPG. The code property graph combines multiple programs representation into one unified structure. It integrates AST, CFG and DFG. Benefits of this is complete program understanding, static code analysis, software security analysis, vulnerability detection. CPG provides a comprehensive view of source code behavior. this is the sample program we took, and here the functions are tokens. This is the output of the function tokens, how it works. For example, hash include preprocessor, studio.h header, int, keyword, like this many programs, like nearly we have 54 programs, 54 tokens, 18 tokens, and the color combination of these are shown in this. And the next one is AST. This is the graph of AST, abstract syntax tree. CFG, the CFG for the sample code, it goes like this. DFG of the sample code is this. CPG of our sample code, and these functions as the restart, we can give sample program like this. And the continue part are advantages: easy to understand compiler concepts, interactive learning environment, visual representation of code analysis, improves program understanding, useful for students and beginners, demonstrate real compiler workflow, connects theory with practical implementation. Lastly, the conclusion of this concept: the web-based visualize successfully demonstrates the structural representation of C program. The system performs tokenization, AST generation, CFG visualization, DFG visualization, CPG visualization. The project provides an effective platform for learning compiler design concepts and understanding how source code is analyzed internally. It also highlights the practical application of automata theory in modern software system. Thank you.